G'day guys, we've got a chemistry question today, more specifically a theoretical yield style question, which is asking us what mass of lime, which is calcium oxide, can be theoretically obtained by heating 125 kilos of limestone, given that the limestone is 95% biomass calcium carbonate. Okay, so to start with, what we're going to do is we're going to come up with an equation which shows the conversion of calcium carbonate to calcium oxide or lime, and it's going to shed a carbon dioxide. So to start with, what we're going to do is we're going to go calcium carbonate solid, so CaCO3 solid is going to be heated, and it's going to dissociate into calcium oxide or lime, so CaO solid, and it's going to shed carbon dioxide. What we do is we just quickly check to one of them, three of them. Okay, so that's a good start. So now what we're going to do is we've got 95% biomass calcium carbonate. So we're going to work out how much calcium carbonate we're playing with here. So what we're going to do is first of all we need to convert this to grams. So we're going to say 125,000 grams. Now we're going to work out how much mass of calcium carbonate we have. So we're going to go, well, if it's 95% by mass, it means the mass of calcium carbonate is going to equal 0.95 times by this mass here, 125,000, which ends up being 118,750 grams. Cool. Now what we're going to do is, like we should do in most chemistry calculation questions, is we're going to determine the molar mass of calcium carbonate. So we're going to go, well, the molar mass of CaCO3 is going to be equal to the mass of calcium, or the molar mass of calcium, which is 40.08. Add that to the molar mass of carbon, and add that to the molar mass of 3 oxygens. And with that, doing that maths, we get 100.09. Cool. Now, like we do in most calculations involving chemistry, we then have to convert this mass of calcium carbonate into moles. So we're going back, and we're going to go the number of moles of CaCO3 is equal to the mass, little m, over the molar mass, big M, which is equal to 118,750 divided by 100.09. And that leaves us with 1,186.43 moles. Now let's just write what we've got so we don't get confused. Cool. Now from here, what we can say is we need to use our molar ratios. That's why we actually wrote the calculation or the equation down for the reaction in the first place. So we know that with 1 mole of this, it's going to give us 1 mole of that. So we can say the number of moles of CaO is going to be equal to the number of moles of CaCO3, which is equal to 1186.43 moles. Then I've just picked that up straight from there. Now what we're going to do from here is we need to work out the mass. So all we're going to do is, using this number of moles, we're going to go, well, the molar mass of calcium oxide, so of lime, so let's start with that. Big M of CaO is equal to, we've got 40.08 plus 16, which is equal to 56.08. So we can work out the mass of CaO by going the number of moles times the molar mass, which is equal to 1186.43 times 56.08. Put decimal there. And that comes out to be 66,535.12 grams, or, because they give us the initial limestone in kilos, we'll convert this to kilos, and we are going to be left with 66.5 kilos of lime. Cool. So, I think you get the point. Now, so what we've done here is to start with, we've calculated, or we've worked out what the reaction equation is going to be, so we can find out our molar ratios of all of our reactants and products. We then worked out the number of moles of what we were, the reactants. So using the molar ratios, we've determined in the equation here, we can use this number of moles, or not this number of moles, we can use this mass, and after calculating this number of moles, we can figure out what this number of moles is going to be. Is it going to be twice as much, half as much, or exactly the same? Once we did this, we could then just simply calculate the molar mass of calcium oxide, which is this, in grams. And then using that, we can just, our simple number of moles times mass, molar mass equation, we can just come out with our 66.5 kilograms of lime. So again, this one isn't a very difficult question if you guys know what you're doing. It just requires a bit of practice. I'd watch the video a few times, see if you get it. Maybe work through the problem on your own and see if you can do it, and then come back and see if it matches with what I've got. But until next time, guys, definitely keep enjoying your studies and enjoying your chemistry.